So this lesson is for problem 2.3 in samples and populations, and if you're just watching this lesson, you probably need to go back to the previous lesson for 2.3a. This is B. This is for part C. And what we're going to do now is in the previous lesson I randomly picked these people using my graphing calculator to find out the number of movies watched, and from that I was able to make this line plot to see that those were the numbers of movies watched. Now in this part I'm actually going to focus on the sleep hours, the hours of sleep for the same group of 30 randomly picked people from this list. But this time I'm going to make a box and whisker plot with that data. So what I want to do this time is actually, I'm going to use my graphing calculator because that's the easiest way to do this. And so if you haven't learned how to use a graphing calculator to do this, you need to go to one of the graphing calculator lessons for making a box and whisker plot and learn how to do that. So that's the best way to do this. So I'm going to go actually to this button, Stat or List on a TI-73, and hit Enter, or you're already there in a TI-73. And I'm going to put in my sleep hours here. So here you can see there's a 2.0. This is my list. So I'm going to just use these numbers 2, and I can do 0.0, but it'll just give me a 2, and then 7.7. So I'm going to take these highlighted numbers from my list, and there's 30 of them, and I'm just going to input them all into my graphing calculator and have it do the hard work for me of dividing these into quartiles or quarters. And so I'm just inputting all these numbers into my list. Hopefully I did this correctly earlier, and I will have 30 numbers. So again, I'm just taking these from the list. There's that 8.0, and then again from my list 7.5. So the idea here is that I'm going to get a data display called a box and whisker plot, which we've done in previous investigations, and it's going to show me the distribution of the hours of sleep for a sample of the entire 100. Because the idea now is I don't want to have to do this box and whisker plot and put in 100 numbers. It's hard enough to put in 30 numbers in the list. And I think I'm almost there. 8.3, and then the last one 7.5, and there I have 30 entries. You can see on my calculator I have 30 entries. So there's the 30th one. And so again, just taken all these numbers off of my list that were randomly selected in a previous video investigation you've seen me do using my calculator, and now I have them in here, and I want to go and make a box and whisker plot. So I'm going to go up here to second y equals, turn that plot on, and make sure it's on, and that I have this box and whisker plot with the dots on it, and a TI-73, it's the last one on the right. It's going to make it from list number 1, and when I hit enter, it's done. Frequency 1, that's the mark that it's going to leave if there's any outliers. And when I graph this, probably going to have to go zoom, and then the number 9 or number 7 on a TI-73, stat, and there is my box and whisker plot for sleep hours. Now I want to find out what those numbers are in there. It looks like I have an outlier to the left, and so I need that. So if I trace, it shows me that that bottom end of the box is 7. So I'm going to go way down there to the outlier, minimum 2. And now what I want to do is I want to transfer this box and whisker plot onto an actual piece of paper. So I'm going to kind of keep these side by side here. Put this one over here to this side so you can see both screens at the same time. So I need some numbers on my line, and it looks like the lowest number in my data set is at 2, and I'm thinking that even if I look over here, the fewest number of hours of sleep can't be less than 2. It looks like that person had the fewest. So if I start my line here at 2.0, and then I go by half hours, so this would be 2.5 and 3 and 3.5 and 4, 4.5, 5, 6.5, 7. Just keep going across. I need some numbers on my page so I can figure out where this box and whisker plot's going to go. 8.5, 9, 10, 11, 12, and I go right 2, 3, 4, 5. I skip the 6. So that means I need a new sheet of paper to do this again. I will fix my mistake. So try this again. When I make mistakes, I'm glad I caught it, and I can fix it here before I make my box and whisker plot. So again, 2, 3, 4. I'll help myself by putting in the whole numbers first. 5, 6, 7, 8, 9, 10, 11, and if we were off the chart, we'd be 12. Hopefully nobody's sleeping too much more than 11 hours, so this should work. I'll leave those out in between, so you know those are half hours in between, and that will help. And so now that I have my sheet right, I can take these numbers right off of the graphing calculator. And so that minimum, the minimum is 2. It's also an outlier, and so I'm going to mark it down here with a asterisk because that is an outlier at 2. And then when I move my arrow key over to the right, because I'm tracing this now, that first mark, X, is at 7. So 7 is where I'm going to make a mark to start my whisker from. The next mark over is at 7.3. That's where the lower quartile is going to be. So 7.3, if this is 7.5, 7.3 is going to be pretty close to where I started. Then the next mark, if I go to the right, is 7.8 is the median. So this is 7.5, 7.8 is going to be right around here. So you can see I have a pretty small box, which kind of makes sense if you think about what our data is telling us. The next one over, quartile 3, is 8.3, so right about there. And the last one on the right, the maximum, is 9.5. And so right there, 9.5, 9.5. And remember the 3 in the middle make the box. And they attach to the minimum and the maximum. Remembering that this really isn't the minimum, but the minimum in this case is an outlier. And if you think about my data, 2 is definitely not a normal number of hours of sleep. But this sort of middle, this part between 7, 7.3 to 8.2, 8.3, that's pretty normal. That's average. That's where the box tells us. And so that was for my sample size of 30 people. And part of the question would be, was that sample size of 30, does that sample of 30 represent the whole group? Could you say that this average, this middle, tells you about all the people on this list, all 100 of them? Do all 100 of them have kind of that same average? So as a part of this problem, this was my sample of 30. And so one of the ways to figure that out is to compare that to other students. So what you have to do is, if you did this, you could actually use my box and whisker plot, and you could put it on yours as a second one. So I want to find somebody else that did this. And then I want to find a third person that did this as well and copy their box and whisker plot. And I'm just going to show you what I found when I did this activity with some other students. So here was my box and whisker plot from another random sample I did. And then here was another student's, Lauren's, sample. This is what she found from a sample of 30. And then Nathan, another student that I had in class, who I copied his box and whisker plot. This was his box and whisker plot from his sample size of 30. So each of us did a sample of 30. Each of us did our own box and whisker plot. Some of us had the same people in our samples, but this was 3 different samples of the same 100 people. And you can see that the boxes are fairly similar. The whiskers are fairly similar. This one had a little bit lower. And each of them actually had outliers. And so the question is a sample size of 30 enough? And it looks like in this case we get consistent results. And so if we have consistency between our 3 different sets of box and whisker plots, that's probably a good sample size. It might be good enough. What if I look at the same kind of results for when I do a line plot? When I take a line plot, this is my line plot for movies watched. This is a line plot for another student's movies watched. See how similar they are? Here's another one, fairly similar. Again, most of the data clustering in the 0 to 3. So what we really are asking in this investigation is, what's the ideal sample size? Could I have done it with less? Or do I need more than 30 people in my sample size? Because really, ideally, I don't want to have to take every piece of data in here and use it. And really, the idea of this is that, going back to the very beginning of this investigation, because we're kind of coming to the end of this investigation, is when I have a population, the entire group, how do I get information from a small group called a sample that gives me what would be considered a representative group or representative result for the entire population that I could use to predict what the entire population does? In this case, I think I can predict pretty safely from my results and from the results I've seen from others that most people are getting between 7 and 8, a little more than 8 hours of sleep a night. And so my sample size is pretty good at predicting that for the whole entire group. Now we could check that by going through and doing this data analysis for every person in the group, but it's probably easier, like we did, to pick a random sample and use our random set of data to predict for the whole population. So here's our population, these are our sample, and does our sample represent the whole population? And that's a question you'll have to answer here in this investigation.